Hello everyone, in this video we will be solving problem 203, remove linked list elements. The problem statement is, given the head of the linked list and an integer val, remove all nodes from the linked list where the node.val is equals to value and return the new head. If you look at example number 1, with this given linked list and value given as 6, we need to remove these two nodes from it and return the remaining elements as is, which gives us this output. If the value doesn't exist in the list, like example number 2, we need to return the same list as is. And if all of the elements matches the value, we need to return an empty head. Couple of constraints that are given to us are the number of nodes in the list are in the range of 0 to 10 raised to power 4. The value could be anywhere from 1 to 50, and the value of the number could be anywhere from 0 to 50. Now let's switch to whiteboard and discuss how we can solve this problem. Let's start by discussing how it can be solved using the naive approach. In the naive approach, we'll start by iterating through all of the elements in the linked list, compare the value against the value given to us. If it is equal, then we'll do nothing. But if it is not equal, we'll save it in a list. And once we are done with the iteration, we'll rebuild a new linked list using the values in this collection and return it. Let's do a couple of runs to understand how will this work. Starting with node 1, is it equal to the value given to us? The input is 6 as the value. It is not equal, so we'll go into the not equal side and save it to the collection. Updating or incrementing my counter. Next is 2. Is it equal? No, so we'll add it again. Next is 6. Is the value equal? Yes, so we'll do nothing. We'll not add it to the list and continue further. So at the end, we'll have 1, 2, 3 and 4 in the collection, and we'll build a linked list using this and return it. With this solution, our time complexity is O of n, as we iterated through this collection once and then building this new linked list using the saved elements. So technically it is O of 2n, but we'll round it up to O of n. And the space complexity is O of n, as we are building this collection with all of the values that are not equal to the value given to us. Although this solution solves the problem, let's think about how we can optimize it further. To solve this problem, we'll use a recursive loop with one pointer, where the pointer will keep on iterating through all of the nodes in the given linked list, and every time we encounter a node whose value matches to the value given to us, we'll replace it with the next node. Let's start a couple of simulations to understand what I'm talking about. Let's start with node 1. Is it equal to the value? So we'll continue. We'll move on to the next node, which is 2. Is 2 equal to the value? No. So we'll continue. Now we are at 6. Is it equal to the value? Yes. So we'll update node is equal to node.next. We are basically replacing the current node with the next node. That is, node 6 is being replaced by node 4, and the rest of the connection stays as is. After this replacement, 2's next node is 4 and the rest of the chain stays as is. I hope you were able to understand this update. If we continue this iteration further, we'll have 4, 5 and then 6. We again encountered a node whose value is equal to the value given to us, so we'll have to update. As there is no node after 6, node 6 will be replaced by null. With this approach, the time complexity is O of n, where n is the number of nodes in the given linked list, and the space complexity is O of 1, as we are not creating any new collection to maintain the new updated linked list. I hope you were able to understand this explanation. Let me show you how we can implement this using C#. Here's my solution in C#. I start by calling this remove helper method, passing the list node and the value that needs to be removed. In the helper method, I'm first checking if the given node is not null and then comparing its value against the value given to us in the input. If the two value matches, then I'm setting the current node to its next value and then passing or recursively calling the remove method again, passing the next into it. And whatever output I get out of it, I'm saving it back into the node instance. The value does not match, then I'm calling the remove method, passing the node.next instance and the value, and whatever is the output is being saved back into node.next instance. At the end, I'm passing the node instance back after every iteration. This solution, when submitted on LeetCode, beats 100% of the submissions in terms of runtime complexity and beats nearly 32% of the submissions in terms of memory consumption. Thank you for watching this video. I hope you were able to understand this explanation and the solution. The link to the code is available in the description below. Feel free to check that out, and I will see you in the next one. Thank you.